I give you two faucets, both with constant water flow, constant rate of water flow. One pours out. How does the right word? Is that okay? 7 gallons per minute. And the other 8 gallons per minute. So if we open both at the same time, how long does it take to fill the tub? $165 gallons. All right, let's get together and look at this quickly. All right. So I won't even write it down, but just I'm sure at this point I talk about it and you get it, right? So you turn on the faucet and you look at how much water comes out. So now this constant, you all know what constant rate of water flow means. That means in each. So so you notice, yeah. The unit of time that's implicitly chosen is minute. The unit of volume is gallons, right? Okay, so what it says is that each minute, the faucet gives out 7 gallons, and the other is 8 gallons. So that's given to you. So that means if you turn on both at the same time, then in 1 minute, together they give you 15 gallons of water, right? 2 minutes is 30. So in that sense, you can just keep doing it and get multiple until you reach the goal. Except that, as we said, when you see that happening, you're looking at measurement division. Therefore, that means, well, more formally, that is that suppose after 10 minutes, the two faucets together would fill the tub. Now, in 10 minutes, sum total number of gallons of water given up by both faucets would be that many copies of 15, right? Mm-hmm. And that is supposed to fill the tub, which is then 165. Right? So something times something equals something else. By our definition of division, this is exactly the same statement as. You see? Because what's the meaning of this? This meaning is, oh, sorry. Yeah, sorry. Yeah, the meaning of this division is what? This is equal to something means 165 is equal to that something times 15. See? So this you can apply the long division algorithm to it and get it done. Now, the reason I give this to you is just to alert you to the fact that in school mathematics, basically there's only one kind of rate problem, no matter how you phrase it. There's only one kind of rate problem. There's no two ways about it. Because we're so restricted in what we can do, you end up just doing the same thing, but you phrase it differently. So now, look, what would this look like? I can rephrase it in terms of a train, if you can imagine very slow-moving trains. Huh? Two down, 165 miles apart. And the two trains right on parallel tracks come at each other. One runs at
7 miles a minute.
yeah, I guess 7 miles a minute. Yeah, that would work. 7 miles. That's even realistic. 7 miles a minute, and the other runs at 8 miles a minute. After how many minutes would they meet in the middle? Then you do exactly the same. Or now, two people mow a lawn together. One can mow 7 square feet per something, and I think I got the right number. What's realistic? 7 what?
7 square yards.
Square yards, maybe 7 square yards per minute. How's that? And the other, you're not working hard enough, Maureen. That's why it is. The other can mow 8 square yards per minute. Now you allow both of them to mow together, but with the proviso that they never interfere with each other and they dovetail their works perfectly. Right? Right? Now I have a lawn of 165 square yards. How long does it take? When both of them go at it together, would finish mowing the lawn. And I don't want to go through this. Now, you paint a house, the surface area of the house is 165 square yards, whatever, and all the same. But you have to see. But look, if you do not do not know the underlying reasoning, you have to memorize all these templates. In each one you say, oh yeah, it's like this. This one is like this. That one like this. But you understand it, then of course the reasoning. In fact, if you only look at the equations and forget the words, you realize every single one of them is going to look exactly like the other. Right? The same equation. No matter what you say. Mowing the lawn, painting the house, typing word. I don't know. That may be harder, but whatever, trains going at each other. They're all the same. Same equation. Yeah? So if you teach, you be sure to alert your students to the fact that there's only one kind of rate problem. All the same. If the students fail to see the similarity, all it means is that they have not gone through the reasoning, and therefore they don't see that logical reasoning always produces one single set of equations.